In this video we're going to check the dynamic range accuracy of the 4262 digitizer and then relate this to the accuracy of the total harmonic distortion measurement so as we can determine how accurate total harmonic distortion measurements can be made with this instrument of audio systems. To provide a high accuracy signal, I'm going to be using the internal generator, which again is a 16-bit DAC, so it produces a very clean, in this case, sine wave. I'm going to select 1 kilohertz and set the amplitude to 900 millivolts. This signal then has been directly connected to the channel A input, so we're acquiring the data into the 100 kilosamples of memory. And here we see the signal. I'm now going to zoom in so we can see some individual cycles of the 1 kilohertz. So here we see the acquired signal. So now I'm going to use this acquisition and move to the spectrum domain and make some high accuracy measurements of the signal to noise ratio. So in the views menu I can add a spectrum view. So now we've added a second view here, the spectrum view, which is amplitude against frequency, and here we can see the fundamental, which is the 1 kilohertz signal, and in fact we can just start to see the second and third harmonics. So now I'm going to use the measurements to measure these harmonics more accurately. So we're going to signal source from channel A, and the measurements I'm going to select is the total harmonic distortion in dBs, and add that measurement. So here we see the measurement, so it's saying the harmonics are minus 93 dBs down from the fundamental. And to make a second measurement, I'll add the signal to noise ratio measurement. So here we can say signal to noise and add that measurement. So again the mean noise is down at minus 97 dBs. In fact, we can minimize the size of the time display now and maximize so we can view the spectrum. So here we could make a similar measurement with cursors. So I could put on 2 cursors, and I could put one cursor on the top of the fundamental and the second one down on the second harmonic. So again that's giving us a similar measurement of minus 96 dBs down. The noise floor is below that, but we can average out the mean noise, so we can, in the spectrum setup, we can do an average of the acquisition and apply that measurement. So this will reduce the noise floor and give us more resolution on the harmonics, but we can see they've not actually changed. They are still down at minus 93 dBs. So the predominant factor in this particular measurement is the second and third harmonics. Finally, I'm going to turn on total harmonic distortion measurement and use the percentage of distortion. So here we now added total harmonic in percentage, so we can see it's around about 2 milli%. So this gives us an indication of the accuracy of the measurement system. So it means that any audio system that is measured, we can measure distortion from the audio system which is greater than 2 milli%. So this will give a very high accuracy of measurement capability.